we're going to do a little review of all the probability work we've done so far. You have a bag of marbles that contains 10 orange marbles, 5 purple marbles, and 15 green marbles. So that's a total of 30 marbles in the bag. You pick one. Push pause and calculate each of these 4 probabilities. Once you're done, push play and compare your work to mine. If you need to, push pause one more time so that you can take the time to compare your work to mine. Once you're ready, push play and we'll go on to the next section. You have a bag of marbles that contains 10 orange marbles, 5 purple marbles, and 15 green marbles, just like in the section above. You pick one, you put it back, and then you pick another one. What is the probability that you get an orange and then a green? Well, when you go to pick the orange, there are 10 oranges in a bag of 30 marbles. There are still 30 marbles in the bag because you put the orange one back and you're looking for a green one. There are 15. Each of these fractions reduces, the first to 1 over 3 and the second to 1 over 2. So when we multiply, we see that we have a 1 in 6 probability of getting first an orange and then a green. Doing the problem right below that, what's the probability of getting a green and then a green? Well, when we go to pick the first green, there are 15 green marbles in the bag, and there are 30 marbles total. But we put this marble back before we try to take the next one. So when we go to take the next green marble, there are still 15 green marbles out of a total of 30 marbles. Each of these fractions reduces to 1/2. 1/2 times 1/2 is 1/4. Doing the problem next to that, we're looking for the probability of getting a blue and then an orange. Well, there aren't any blue marbles in the bag. And then we go to take an orange, and there are 10 out of 30 orange marbles. Well, 10 out of 30 reduces to 1 over 3. But since that multiplies to make 0 out of 90, we're not too worried about it. That's just equals 0. The other 3 problems in this section are part of your independent practice for today. Let's look at the next section. We're dealing with the same bag of orange, purple, and green marbles. But this time, once we pick a marble, we do not put it back. So when we go to calculate the probability of an orange and then a green, it starts out just like in the previous section. We have a 10 out of 30 chance of getting an orange. But now there are only 29 marbles in the bag because we kept the orange one. Of the 29 marbles, 15 of them are still green. The first fraction reduces to 1 out of 3, and we can see that the 15 reduces with the 3 as well. So our probability of getting an orange and then a green, if we don't put the first marble back, is 5 out of 29. Let's take a look at the one right below that. What's the probability of getting a green and then a green? Well, when we go to take the first green, there are 15 green marbles out of 30 marbles. But when we go to take the second, we're holding a green marble. So there are only 29 marbles in the bag and only 14 of them are actually green. Reducing the first fraction, we see that we can still reduce further. And we have a 7 out of 29 chance of getting a green and then another green. I'm going to leave the blue and orange one for you, but I'm going to do the one in the upper right-hand corner. The probability of not green and then green. Well, since 15 of the marbles are not green, then since 15 of the marbles are green, then 15 are not green. Out of 30 marbles, there's now only 29 marbles in the bag. Of those, 15 of them are green because the one that we're holding in our hand is not green. We can reduce the first fraction to 1/2, but we can't reduce anything else. So we have a probability of 15 out of 58. The other 3 problems in this section are for you to try on your own as part of your independent practice. Okay, we're back to a standard deck of playing cards. We know that there's 52 cards total in the deck, and this is just like all the other days' lessons where we're looking at playing cards. This time we're just looking to draw one card. So for the first one, we have what's the probability of getting a red? Well, we know that there are 26 red cards out of 52, or you might remember that half of the cards are red. All right, push pause and try the other 5 problems in this section. When you're done, push play and compare your work to mine. If you need to, go ahead and push pause to take a moment and check your work. When you're ready, let's move on to the last couple of sections. We're still talking about a standard deck of playing cards. In this next section, we are putting the card back before we draw the next card. So let's calculate the probability of getting a spade and then another spade. I'm sorry, a 10 of spades and then another spade. So there's only one 10 of spades in the total deck of 52 cards. So when we go to draw the next card, there are only 51 cards in the deck. Now we're hoping to get a spade, but we're holding a spade in our hands. So instead of there being 13 spades, there are only 12 spades remaining. Now 1 out of 52 doesn't reduce, but 12 out of 51 does. Those are both divisible by 3. 4 and 52 also reduce, so we can reduce a little further. And that gives us a probability of 1 out of 208. The other problem in this section is part of your independent practice for today. Let's look at the related problem, but in the situation where we don't put it back. So when I go to draw the 10 of spades, I still have a 1 in 52 chance of getting it. But now, I got to go back. The probability that we did up above is the one for this one. So let's pull that work down here. Because notice, I said we kept the card, right? 51 of the cards are only left in the deck, and there are only 12 instead of 13 spades. Sorry, I got ahead of myself and did the problems in the wrong order. So let's back up and do the one where we actually put the card back. If we put the card back, there'll be 52 cards in the deck each time we go to pick. When we go to pick the 10 of spades, there's only one of those in the deck. But when we go to pick just any spade, there are 13 of those. That does reduce to 1 over 4. When we multiply through, that's where the 1 over 208 comes in. I had the right answer and the wrong work the first time I did it. So we do need to come back down here and fix that final answer. I gave you the wrong denominator. The setup down here is fine for not putting it back, but when we multiply, we're going to get 1 out of 221. Sorry for the mix-up. All right, you have 2 problems, one on the right in each section here, to do as part of your independent practice. When you're finished with all the green starred problems from this video, take a picture of your work and upload it in the Google Classroom. You have completed your last homework assignment for this school year. Congratulations.